In the previous video, I had discussed about RSA crypto system. So in this video, I shall be discussing about the RSA digital signature scheme. Coming to your RSA crypto system, so it is a method where a message is being encrypted using two different keys. Hence, it is called as asymmetric encryption technique. So the same RSA method is being deployed to provide a security to your digital signature. So how do we use this RSA and create a digital signature? So that's what we are going to learn here. So we know that we had three different steps in RSA crypto system. The step number 1 is to generate key. The step number 2 is to encrypt the given message, and the step number 3 is to decrypt the message. Almost the similar kind of steps are also involved in RSA digital signature scheme, and here again we are going to generate two different types of keys. One is a public key, the other one is a private key. So those steps are very similar. So in the previous video I had explained the first thing is what we have to do is we have to take the highest prime numbers, which is P and Q, and then we have to perform a product of those two numbers, and we have stored that value in N, and then we are supposed to calculate P minus 1 into Q minus 1. So this is what we call it as Euler's totient rule. So we apply a Euler's totient rule to calculate pi of n. Once we have calculated pi of n, what we do is we are going to generate a public key, where your public key is been identified by E and your private key is been identified by D. So I'll consider this as your public key and D as your private key. So now, using the previous equations, I would like to generate my public key. Now what I do is I will select the public key in such a way that so the GCD of your E and your pi of n should be equal to 1. So this we have seen in the previous video. We have taken an example and we have seen how to take the value of your E. Once we have taken your public key, now it is time to select the private key. How do we select the private key? The private key D is selected in such a way that the product of D and E and the mod of pi of n should be congruent to 1. We have already taken E and we know what is the value of pi of n, and what we do is we perform the product of your D and E and then perform the mod operation with pi of n such that they are congruent to 1. So now we have selected one of our public key and we have selected one of our private key. So this is the same step even which we are going to use it in your RSA digital signature scheme. So now what difference that makes with your RSA crypto system and RSA digital signature scheme is, so now we will see how you can provide your security to your digital signature using your RSA algorithm. So here, as a part of the second step in RSA algorithm, we know that how you can perform the encryption. Now this is what we have discussed, how you can create a ciphertext where P is your plain text and P to the power of E, and we perform a mod operation with N. So that is going to generate your ciphertext. Now we have to create a digital signature against your message. Now M is a message. Now I am supposed to create a digital signature against your given message. The only difference that what we do in encryption and in digital signature with respect to your RSA algorithm is we are just swapping the roles of your two different keys. Now here, to generate a cipher key, we had taken a public key, and now to generate your digital signature, now we are going to take a private key. A digital signature is being created with the help of a private key against a given message. So S stands for a digital signature. A digital signature is being created against the message with the help of a private key by performing a mod operation with your N. Now to verify whether this digital signature is appropriate or not, like a decryption method, so what we do is, so in the decryption, in the previous video I had explained you about the RSA decryption method, where I am going to extract a plain text from the ciphertext with the help of a private key. As I told you that the roles are being swapped here. Now to verify whether my signature is authenticated against the given message or not, what am I going to do is, I will take the given signature and I am going to make use of the public key to check whether the message is appropriate against the given digital signature or not. So here in the encryption technique, we had taken a public key to convert your message into a ciphertext, but in the to generate a digital signature we had taken a private key. And in the decryption method with respect to your RSA algorithm, to take a plain text back, we had taken a private key and we had generated the plain text. But to verify whether my digital signature is valid against the sent signature, what are we going to do is, we are going to take the public key. So to give more details about this particular RSA digital signature scheme, probably this diagram would help you to understand better. So I'll show you the diagram here. Now let me assume we have two different users. One is Alice is the one user, the other side the Bob is the user. So now Alice has to generate a digital signature, and the signature along with the message is being sent to the Bob. Now Bob verifies the signature and check whether the particular message is being sent by the appropriate user or not. Now how do we perform that? Now what we do is, Alice is going to generate a digital signature called as a yes using a message against the message. Now we have a message and we have a private key. With the help of your private key, see, we know that D is your private key. Now Alice is going to generate a digital signature against your message using your private key. That is what I had explained you in the previous slide. So that's how you calculate. M to the power of D mod n will give you the digital signature. Now Alice has created a digital signature using the private key against the sent message. As a part of it, what Alice does after creating a digital signature, he sends the digital signature and the message to the Bob. Now S and M are being sent from the Alice to the Bob. Now what Bob does is, Bob receives the signature and the message and checks whether this message is being sent by the Alice itself or not using your digital signature. He verifies the digital signature belongs to the Alice or not. Now he receives the signature from the Alice and the message. Now what he does is, now Bob will always have the public key. Now using the public key, he is going to check whether the message that is being sent by the Alice is valid or not. So we make use of this public key. S to the power of E mod n is used to check or to obtain back my message. As a part of it, a message is being generated and we call that message as M dash, and the next step what we do is, anyhow Alice has sent the message M, and now Bob has been generated a message called as M dash using the public key which is generated against your digital signature. Now what he does is, he is going to take your M in such a way that M should be congruent to mod n. He checks this condition whether M is congruent to M dash mod n, where M is a message which is sent by the Alice and M dash is a message which is being generated by the Bob using the public key against the digital signature. If they are congruent to one and the same, say yes, M and M dash are congruent. If it is true, then the message is being accepted. If it is false, then the message will be totally rejected. So this is how your RSA digital signature scheme works. So we can also go one step forward against it. I mean, where we can make use of your hash function and see that you provide a better security for your digital signature and verify whether your signature is appropriate or not. So here Alice is one user who is going to put a signature, and Bob is a verifier who receives both the digital signature and the message. So he is going to verify whether the message sent by the Alice is appropriate or not, or he just checks whether it is being sent by the Alice or not using the digital signature. So going ahead, how do you deploy your hash function into your digital signature, that we will see now. Now this is what we call it as RSA signature on message digest. Only a small modification that what we have done is, now rather than generating a digital signature against your message, now what we do is the message is also being encrypted using your hash. That means a message is being sent to an hash function which is going to generate a hash digest. Now we have got an hash digest using our message through your hash function. Now this hash digest is given to your private key to generate a signature. Now what Alice does is, he is going to sign or generate a digital signature not based on the message rather than the message digest or hash digest, that is D. So in the previous slide the digital signature was generated against the message. In this slide you can see that the message, I mean this digital signature is being generated against the message digest, or it is also called as a hash digest. Now Bob receives, one is the digital signature, the other one is the message. And now what is the function of your Bob? Bob has to verify whether the signature is being sent by the Alice or not. Now what he does is, once it is been received, now the Bob is going to make use of a public key and generate your D dash value. So this is your message digest value which is being generated against the sent digital signature with the help of a public key. Now he is going to create a D dash, that is your message digest, which is being developed or created against your public key against your sent digital signature. Now as we know that we have received the message, and again the message is being sent to your hash function creating a message digest. So this is your message digest with respect to M, and this is your message digest which is being generated from the public key against your sent digital signature. Now Bob is going to verify again whether D is congruent to D dash mod N. If D is congruent to D dash mod N is true, then the message is accepted. Otherwise the message which has been sent will be rejected, specifying that the signature is not appropriate and the message is not being sent from the appropriate person, because there might be a third person who can intrude in between, so he can create a fake signature and he might send you. So in the upcoming video I shall be explaining one more algorithm which will help you for generating a digital signature. Thank you.